Okay, guys. So today we will continue our discussion on functions and procedures. Okay. So we have seen pretty much what functions are, but this is more of a formal introduction to the concept of subprogramming. Okay. So what is a subprogram? Okay. A subprogram, theoretically speaking, is a block of statements, okay, which is packaged as a unit, and the block of unit performs a specific task. Okay. uh, Now this block of statements, this unit, can be called in a program several times whenever that specific task needs to be performed. Okay. So the analogy here is it's like a recipe. Okay. It's like a recipe. So what happens is, in a recipe you have a list of things that you would do, right? So let's take a recipe for making tea, right? So you start with, you boil water, right? uh, you add you add tea leaves, right? And I don't know, uh, let simmer or something, I'm not sure. Okay. And for um, pour into cup or something, right? Pour into cup. Now, so this recipe for tea, it consists of 4 steps, right? Now what you do is, you would package these 4 steps, as a unit and call it make tea, something like this, right? So whenever you want to make tea, or when you want to ask somebody to make tea for you, you would not have to specify these 4 steps, right? So when you ask someone to make tea, you would not say boil water, add tea leaves, blah blah blah. You would not say that, right? You would say make tea. And it is sort of assumed that the person knows how to make tea, right? So maybe you taught them how to make tea, right? Maybe you taught them, maybe it's something that you learned yourself, right? Now the idea is, once you learn it, right, once you learn what the steps are, you don't have to spell these steps out, right? You can just say make tea, and somebody who knows the recipe will know how to make tea, right? So essentially what happens is, it makes it easier to think about problems. Okay. Now conceptually, there are 2 types of subprograms. Number 1 is functions, okay, and the second one is procedures. Okay. What are functions? If you have done maths and calculus, you know a function which looks like this, right? Like y equals f of x, and this f is called a function, right? F is called a function. Now what this means is, given x, which is the input, the function will return y, which is the output, right? Now functions return value. Okay. They may take input, like in this case x, and they return a value, in this case it's y, right? So functions return value. The second type is called procedures, which do not return anything. Okay. Now these are conceptual definitions. Okay. Functions and procedures, the differentiation between these two is purely conceptual. Python does not make any distinctions between a function and procedure in how they are defined, how they are defined, or how they are called. For Python, it's essentially the same. Okay, how you define a function and how you call a function, and how you define and call a procedure are same. Okay, the only difference is functions return a value, and procedures do not return anything. Okay, now why do we distinguish between these two? Okay, so think of a function as some set of steps that take an input and return an output. Okay. On the other hand, procedures is sort of a more complicated. Okay. They and a good example of a procedure would be sort, S-O-R-T, sort. Okay. So what happens with sort is it's a very widely used procedure, and what it does is given a list of numbers which can be in any order. Let's say 2, 6, 1, 3, 9, 7, 5, so on and so forth, right? Given a sequence of numbers which are unordered, right? Unordered. The sort procedure will give you the sequence which is ordered, okay? Either in ascending order or in descending order, right? So it will give you 1, 2, 3, 5, 6, 7, 9, okay? And sort, as it turns out, is a widely used procedure, okay? So sort does not return anything per se, okay? It just takes the list and it sorts it, okay? It does not return an output, it just does it, okay? So the difference between a function and a procedure is that, generally speaking, as a rule of thumb, procedures are more complicated than functions, okay? But that's not always the case, so it will completely depend upon how you choose to program it, okay? As I said, Python does not make any distinctions between functions and procedures, okay? So it's completely up to you. But conceptually, functions will return something, procedures won't, okay? Now, what is procedural programming? Why do we need procedures in the first place? So the idea is to iteratively divide or subdivide the initial problem into smaller problems, okay, subproblems. And if we go back, right, if we go back to our tea making example, we said that the recipe for tea involves boiling water, right, adding tea leaves, let simmer, blah, 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 right? Now, if you think about it, you can break each of these steps down. If you have to like teach a robot how to make tea, you will have to break each of these steps down into smaller steps, okay, sub steps that the robot can understand. For instance, what do we mean by boiling water? Okay, what do I mean when I say boil water? The boiled water itself can be subdivided, right? So like take a pan, pour water, right? Place on oven or stovetop, right? Stove. Switch on. Watch until. Watch. WATCH. Watch until. How do you see how it boils, right? Watch until bubbles or something, right? So even the step boil water consists of all these smaller sub steps, right? So when we say make tea, we break it down into 4 steps, 4 sort of large steps, but each of these steps can be further broken down into smaller and smaller steps, right? But so why do we do this? Why do we make it simple? Okay, uh, why do we take all these steps and call it boiled water? Because it makes it easier. It makes it easier for us to reason about the problem, to think about a solution, right? Once you break it down into smaller sub-problems iteratively, not all at once, iteratively, okay? It lets us think of the problem, try to solve the problem more efficiently, okay? So, as I said, large problems can be very difficult to debug and maintain as well, okay? So what happens is you start with a big problem and then you break it down into smaller sub-problems, right? And each of the sub-problems can be broken down into even smaller and smaller problems, each of which can be solved individually as a small program, okay, as a small program. As it turns out, once you do the programming, right, if you have a small program, it's easy for you to test it, okay, to test it, to debug it, which means to correct errors and to test it. And that's very important, okay. The smaller your problem is, the easier it is to test, okay, and the larger your problem is, okay, the more difficult it is. So once you divide a bigger problem into smaller and smaller problems, what you can do is you can write programs for each of these subproblems, right? Write a program for each of these subproblems, and then call these subproblems or subprograms from the main program, okay? It's like you are the manager, okay, and you have multiple employees under you, right? Each of these employees know what to do. They are given separate tasks and they are good at their tasks, okay? And all you have to do is coordinate between your employees. That's it, okay? And that makes your life easier because you know that your employees would know what to do, okay? They are experts in what they do, right? So you don't have to care about everything. All you need to care about is how to coordinate between your employees, okay? How to get the bigger thing done, okay? You see the bigger picture. And the idea is your employees will know what to do, right? They're good at it. And that's something that we use in subprogramming as well, okay? Each of these programs are correct. They are tested, okay? They're tested to be working, right? And once you know all your programs are working, right? All your subprograms are working and they're tested to be correct and they are stable, right? You can then call these subprograms from a larger program. So you don't have to test the large program. I mean, you'd obviously test it again, but it makes it much easier if there is a problem to figure out where the problem is, okay, and fix that problem. So that's the advantage of procedural programming, okay, and that essentially means using procedures. Procedural programming means using procedures, okay. So you break the large program down into smaller parts, right, each of which performs a clearly defined process, right, just like the manager and employee relationship, right? You are the manager, your subprograms are the employees. Each of them have a clearly defined process. They know what to work on, right? And they are good at it, okay? They are good at it. You can trust them, okay? And these subprograms are easier to test and maintain, okay? Now, another concept, a sort of an extension of procedural programming is modular programming, okay? Modular programming. And in modular programming, subprograms of common functionality are grouped together into separate modules, okay? An example is the math module in Python, which contains square root, sine, cosine, right, and stuff like that. So these are all mathematical functions, so they are placed in the math module, right? So when you write a program and you want to use square root or sine or cosine, what you do is before you actually use them, you'll say import math, okay? And then when you call these programs, you'll say math dot square root or math dot sine, right? So this math module is nothing but it's like a file. It's essentially a file, okay, which contains all these functions, okay, sine, cosine, so on and so forth. Essentially, it's just a file, okay, and all these functions, all these related functions, right, the mathematical ones, are kept in a single file, one file, right? We have seen other examples of modules as well. Remember once the game that we did, the number guessing game, we used a random module, right? So we imported random before we actually called the rand int, right? So we used a method to get the random integer between a range of numbers, and we imported the random module. So all the procedures or functions that you use to call to generate random numbers are placed in the random module, which is again just a file, nothing else. Okay. Now we have seen uh, examples of functions or procedures that are predefined or built in Java, right? For instance, we have been using input for a while, input, right, to get data from the user, right? Now that's a function that has been defined in Python. We have been using things like print to print to the output. Again, this is also defined by Python, right? You didn't have to define it. But we know that certain functions, you can define your own functions and procedures, right? And the general form of how to define a function looks like this, okay? So you start with the def, stands for define. It is a Python reserved keyword, okay? It stands for define. So this is what you use to define a function. And then you give the name of the function, whatever name you want, right? It follows the same rules as variables. So you cannot start the name with a number, okay? It has to be a letter or underscore, and then it can be any combination of letters, numbers, or underscore, okay? Letters, numbers, and underscores. And the name of the function should be something that sort of gives a hint as to what the function achieves, okay, or what the procedure achieves, okay? The name can be anything you like as long as it follows the same rule as variables. Now, the function can also have a list of arguments, okay, and this can be 0 or more. So function can take one argument, 0 argument, like no arguments, right? 1 argument, 2 argument, any number of arguments, okay? So think of this black box example that we had, the black box, right? So you can have a function which does not take any argument, right, but returns something. Can you think of an example of such a function? An example of such a function is random, right? The random that we used, okay? It does not take anything, it does not take any arguments, but it gives you a random number. Right? So the number of arguments can be 0 or more, and arguments essentially means input. That's it. It's a fancy name for input. Okay, so your function or procedure, whatever it is, it does something, right? Now it can take a list of inputs. It cannot. It's optional, but it can as well, right? Then you have either one statement or a block of statements. Oh, by the way, you also need this colon right here. Okay, you will need this colon. After that, you have a statement or a block of statements, and remember, a function is nothing but a block of statements packaged as a unit, right? So this is the block of statements that you're packaging as the unit, okay? And once you're done, you can return a value or a list of values, okay? 0 or more values, okay? 0 or more values, okay? And these values are returned to the caller. The caller is the guy who calls the function, right? Who calls the function. So in the manager-employee analogy, the manager would be the caller, okay, and the employee would be the function, right? Now again, these values are optional. If you have if your function returns no value, it's essentially a procedure, right? And if it returns a value, it's a function, and it can return 1 value, 2 value, 3 values, and so on and so forth, any number of values, okay? Now, one of the things that's very essential is a function must be defined before it's called, right? Which sounds intuitive, but what I mean is, if you are from a different programming language, such as like Java or C++, right? These programming languages will let you do something weird, okay? So you can write a piece of code and call a function and this function will be defined after it's called. Okay, so programming languages like Java or C++ will let you do this, not Python. Okay, in Python, a function must be defined before it's called, right? So you have to have this definition before you actually use the function. Okay, and a function behaves as a black box. Okay, so once the function is defined and tested, once the function is defined and tested to be correct and stable within the system, you just use that function as a black box. Okay, so once you know, let's say you are using the sort function again, or sort procedure, right? Once you see that sorting gives you the correct results, you won't bother with this anymore, right? You'll just use this as a black box, like a Lego, right? Now, here are some examples of functions. Okay, now this is a function, a user-defined function. Okay, this is user-defined function that takes two numbers and returns the sum. Simple, right? So in the general form, we have a def and a name and the list of arguments, right? So def is common, it's there, right? The name is get sum. That's the name we have decided to give it. Okay, you can name it anything. You can call it, I don't know, add or add as well. Okay, but we decided to name it get sum, and then we give it the list of arguments. In this case, it takes two numbers, right? It takes two numbers. So we give it two arguments. And we know that these numbers are integers or floats, right? Anyways, and then all we do is we add them and save it in result, right? Save in this variable result. Result equals num1 plus num2. And then we return result because we return the sum, right? So we return result. Now, in the general form, we said that the return statement will return a value, value 1, value 2, 1, so on and so forth, right? So in this case, we return result, which is the value, which is the variable that contains num1 and num2, the addition of these two numbers, right? But as it turns out, we don't have to return a variable. We can also return an expression. So this get sum can also be written as return num1 plus num2. Okay, so you can return a variable, return a variable. You can also return an expression. Okay, in general, anything that evaluates to a number, anything that evaluates to a number can be returned from your function. Okay, so you can also return a constant. Let's say you have a stupid function that returns incorrectly. Okay, it returns 0, regardless of what these numbers are. Okay, so you can say get sum, right, num1, num2, and then you return 0. Okay, you return 0. So you can return a constant, a variable, or an expression. Okay, now a function may also return multiple values. So just like we saw here, right, just like a function can take 0, 1, or more arguments, it can return 0, 1, or more values, right? So in this example, this function returns the sum as well as the difference of two numbers, right? So it takes, as usual, it takes two arguments, right? And then calculates the sum, s equals num1 plus num2, and then calculates the difference, d equals num1 minus num2, and then it returns s and d. Okay, so the syntax of returning values is using a comma, okay, using a comma. And the space is immaterial. You can just say SD without a space, okay? And just like before, you don't have to return variables. You can also return expressions. So you can say return num1 plus num2, comma num1 minus num2. You can also say this, right? So any function can return a constant, a variable, or an expression, okay? Now, how do we make calls to a function? So as we know that a function must be defined before it's called, right? So in this case, in this example, we define a function which is called cube, which is named cube. The name of the function is cube, okay? And as you might have guessed, the cube takes a number, okay, and then it cubes it, right? It raises the number to the power 3 and then returns the result, right? Now, how do we call this function? Okay, so let's say we want to calculate the result of the expression y equals x to the 3 x cube plus 1 over x, right? And we want to find the result of this expression, this addition, okay? So the first thing we do is we let the user enter the number x, whatever x is, right? We don't know. So x is the number that the user entered, right? Now let's say x contains the value 2. Let's say x contains the value 2. Okay, that's the number the user chose, okay? And by entering, I means just typed in 2 and then press the carriage return, right? Now, the next step is calling the function. And the way we call the function is just type the name of the function, right? The parentheses, add a parentheses. And then if the function takes an argument, pass the argument, right? Give the number, give the function whatever you want to uh, pass it as input, right? So in this case, we want to pass the value of x, right? So you give x as the input, right? That's how you call a function. So it's very similar to how you define a function. So this part would be exactly the same, okay? Exactly, not exactly, but very similar, okay? So name of the function, parentheses, right? And then the input argument that you want to give to the function. Unlike the definition though, you don't need this colon, right? You don't need that. So all you do is cube of x. The second part is you can assign, if the function returns a result, you can assign that result, you can save that result somewhere, right? And the way you do it is you can say, in this case I say cb equals cube, which means whatever the value that's returned by this function call, save the value in the variable cb, okay? So cube x, if the variable x has the value 2, cube x will return 2, right? 2 raised to the power 3, which is 8, right? And that's the result that is returned. So cube of x would return 8, and cb would try to catch the value returned by cube of x, okay? So cb will now contain the value 8. And then we say y equals cb plus 1 over x. And as we know, cb contains 8, and 1 over x would be 1 over 2. So this would be 8 plus 1 over 2, okay? And then we print y, okay? We print the value of y. So the best way to think about this would be, all you do when you call a function is, okay, to reason about the program is, you just replace the numbers with their values, right? You just replace the number with their values. So for instance, initially, x would be whatever the user enters, right? So let's say replace x with whatever the user enters, let's say 2. And then cb equals cube of x, which is cube of 2, right? And when you call cube of 2, instead of number, you say 2, right? And then instead of num raised to the power 3, you just say 2 raised to the power 3, which is 8, right? So replace the result with 8 and then return 8. And this 8 would be return the entire cube of 2, return the entire cube of 2 with 8, because essentially, right, when you call a function, you can replace that function call with the result of the function call, right? So CB would now contain 8, so replace that, replace this. So y would contain 8 plus 1 over 2, replace y with whatever the result is, right? 8.5, right? And that's your answer, okay? So the best way to reason about a function is, all you do is you just keep replacing the values, okay? You just keep replacing the values. Now that's one way to call a function, okay? You call the function, you pass it an argument, and if the function returns something, you can save that return in a variable. That's one way of doing it, okay? There's another way. You can call the function directly in an expression, okay? So instead of saving the cube in a variable and then using that variable in the next expression, you can use the function call directly in the expression as well, okay? And that's what we do here, okay? So instead of CB equals cube of x, we just say cube of x plus 1 over x. And again, you can reason about this if you keep replacing the values, okay? If you keep replacing the values. So for instance, x equals 2, float of input, let's say the user enters 2, so x would be 2, right? X would be 2, and then cube of x would be cube of 2 plus 1 over 2, right? Now cube of 2 would be, go back here, cube of 2, so the num would be replaced by 2, right? So result is 2 raised to the 3. So when you return result, replace the value of result with the actual, replace the result with the actual value, which is 8, okay? So replace the entire thing with 8, okay? And in this cube of 2, replace this entire thing with the value it returns, okay? So the answer is y equals 8 plus 1 over 2, which is 8.5, right? And that's what you print, okay? And you can keep doing this, okay? You can keep doing this. You can keep making your program shorter and shorter. So instead of printing y, why not do this? You can also do this, right? So you can pass a function as an argument to another function. So in this case, the print, you know that print takes an argument, right? Print takes this argument and that's what it prints. As it turns out, print will also take an expression, and that expression can have, as we seen before, can have a function call, right? So you can say x equals float input, enter x, okay? And then print cube of x plus 1 over x. So this will print directly, okay? And what happens is, when you pass an expression like this, right, what Java will do, what Python will do is, it will solve this expression from the inside out, okay? So as you know, it's again the PEMDAS rule, right? PEMDAS. And the first thing that we do is the parentheses, right? Parentheses. So in this example here, okay, in this example, the first parentheses is this one, right? X. So this x would be replaced by whatever the value of x is, which is, let's say, 2, okay? So this x would be replaced by a 2, okay? So essentially this now becomes cube of 2 plus 1 over x, right? 1 over x. Now the other thing is, in function, when you have a function call, the function call sort of behaves like a parentheses, okay? So think of this function call as the set of block of statements enclosed within a parentheses, okay? So what happens is, in cube of 2, think of it this way, cube of 2 is in a parentheses. So this would be solved next, okay? So it will say cube of 2, which as we know is 8, right? So it will say 8 plus 1 over 2, right? So you can pass a function as an argument to another function as well, okay? So a function can replace a variable in an expression, okay? Let me write that down. A function can replace a variable in an expression. Okay, which means anywhere where you use a variable, right, you can use a function instead. Okay, and that's what we do here, right? Here we initially used a variable cb, but then we replace this variable with the function itself, which is the cube of x, right? That's what we did here, right? That's what we did in this slide. Okay, right? So initially we were using cb, but then we replaced cb with the cube itself, right? So you just keep on replacing. Okay, and that's a good way to reason about the flow of the function. Okay, it's a very good way to do so. It's a good exercise. Okay, now functions are not executed unless called. Okay, so this is an example of a program that prints a greeting. Okay, prints a greeting, and the greeting is how are you. Okay, so that's the function, and again we must define the function get message before we call the function, right? So this must be first, and only then we can call the function. Okay, anyways, so this is where the main code starts, and remember that all the blocks that are tabbed, that are indented, right, indented using a tab, would be part of the function definition, right? So this entire block of code is part of the function definition. Okay, anyways, so once you get out of that indentation, okay, you start with the main code. Okay, anyways, so here we print hi there, right? That's what we print first, and then we say a equals get message, and then we print a. So a function, which in this case is the get message function, will not be executed unless it's called. So although the function has been defined, unless you call the function explicitly like this, right, it won't be executed, which means these set of blocks won't be executed. So the difference between defining a function and calling it, right, define versus call, is knowing versus doing, essentially, right? Knowing versus doing. Okay, so think of a recipe. Okay, a recipe to make tea. You might know the recipe, but that doesn't mean you're doing it, right? So you may know how to make tea, but unless you make the tea, you're not making tea, right? Does it make any sense? Okay, so there is this function definition, and then you have to call the function. So the definition is you knowing what to do, and then calling it is you doing it. Okay, now a function will not be executed unless it's called. Okay, also the function would be executed in the order in which it's called. So in this example, we say the output would be hi there, how are you, right? Hi there, how are you? Because hi there is printed first, and then we get the message which returns how are you, and then we print that message, right? So it says hi there, how are you, right? Now if we were to change this, right, if we were to change this, so if we were to print move this print statement here, right, if we were to do this, it will then print, it will print how are you, and then it would say hi there, right? So the order in which the function is executed with respect to your main code will completely depend upon how it's called, right? And if you don't call it, if you don't call this, it will just say hi there. It will just say hi there, right? It will not print anything else. Okay, so a function will not be executed unless it's called. Okay, the difference between knowing and doing. Okay, now arguments to a function is essentially, as we said before, if you think of a function as a black box, the argument is what you give the functions as input, right? These are the input. An argument is nothing but a fancy name for input. Okay. Okay. So the reason we need argument is that you can change what a function does by changing the arguments, right? Take the simple example of the cube we had before. Okay, simple example of a cube, right? So by changing the value of x, you can change the result, right? Right. So you can say cube 2, right? That gives you 8. Cube 3 gives you 27. 4 gives you 64, so on and so forth, right? So essentially, a function behaves differently, sort of, does different things based on the input provided, right? Okay. So the set of steps will be the same exactly, but the final result would be different, right? So it's like making making tea. You can have Darjeeling tea versus oolong, right? Or something like that. Okay. So the set of steps is the same, but depending on which input you give, your output, the final tea would be different, right? Or green tea, right? Or green tea. Okay. The set of steps for making tea would be similar, but based on your arguments, the final result would be different. Okay. And that's what a function does as well. Okay. The set of steps is the same, but essentially, as I said before, you can think of it as replacing. Okay. It's something that you can replace with whatever you want, right? That's essentially as an input, right? Something that can be easily replaced in the set of steps, right? And that will create a different result based on what you replaced, right? So in this example, in this function, which is called display, takes an argument color, and then all it does is it creates a message. Okay, it creates a string which is there is, and then whatever the color that you sent, and then in the rainbow, right? And then it returns that string. So when you type, when you call these functions with different values, such as in this case we call the function with red, yellow, blue, right? All it does is it replaces the color with red, right? So red, blue, and yellow. So it will say there is red in the rainbow, and there is yellow in the rainbow, and there is blue in the rainbow, right? Like so. So the only thing that changes is the argument that you pass to the function, right? And again, it's very easy to reason about what's happening here. Once you replace this color or replace this display color with display red, okay? So you replace this color with red, and then this color becomes like red as well. And essentially you have a concatenation of 3 strings. There is red in the rainbow, right? And that's what your output is, right? And again, the output would be in the same order in which you called your functions, right? So the first thing would be red, the second would be yellow, the third would be blue, right? So that is the output of this function, okay? So to summarize, arguments of a function are nothing but changing something, okay, in the set of steps that you defined, okay? It's like the input, okay? It's like the input. The making tea example, the set of steps in order to make tea would remain unchanged, but you can give different types of tea leaves to have different types of tea, right? The set of steps will be unchanged, okay? So that's the analogy of an argument. Essentially, it's nothing but an input. It's a slight tweak, okay? It's a slight tweak to your recipe. That's it, okay? Now, in this example, this is another example where an argument, where the function takes 2 arguments, okay? It accepts 2 arguments, and you can do increasingly complicated things with more number of arguments, okay? So the more arguments your function takes, the more sort of generic it is, okay? It can be more flexible, okay? More arguments equals more flexible. Okay, so in this example, what happens is this takes two arguments, a color, okay, a color and exists, okay, and all it does is based on the value of exist, based on whether or not you pass true or false to this exist variable, it will either print there is there is color in the rainbow, or there isn't any color in the rainbow, right? So let's try and work out what's happening here, right? What's happening in this function call. Now let's try with the first one, okay? We print display red and true, okay? So essentially we replace the function call. In the function call we replace, or in the function definition, we replace the color with red, right? So the color would be red, and exists, we replace the exist with true, right? So exists would be true. So if not exists, not means if exists is true, not exists is false. So replace this thing with false, right? This means false. And because it's false, this line won't be executed. This line won't be executed, right? We don't care about this line. And then we print there is neg, replace neg with this. So there is nothing. Color, replace the color with red in the rainbow. So this line will print there is red in the rainbow, right? There is, this is nothing, it's empty. There is a space in between, and then a red in the rainbow, right? Yellow and true would be very similar, so it will print there is yellow in the rainbow, okay? Now let's see the third one, which is black and false. What happens in this case? Okay, what happens with the black and false? So black would replace the color, right? And false would replace the exists, okay? So exists is false. So if not false, okay, what is not false? True. So replace this not false with true, right? If true, neg equals isn't any. So that's the new value of neg, right? Neg is isn't any. So you say there is, not isn't any per se, but ain't any, okay? So you say there is, replace neg with this value right here, plug in this value, okay? There isn't any, and replace color with this value, which is black, right? So replace the color with black in the rainbow. So this one will print there isn't any black in the rainbow, right? So as I said before, as you give the function more and more arguments, the more flexible it becomes, okay? Again, go back to the tea making recipe, okay? So it's like you pass the type of tea, like Darjeeling, oolong, right? I don't know, matcha, something, right? And you can pass it true or false, right? Which suggests, do you want it with sugar or not, right? So Darjeeling with no sugar, right? Oolong with sugar, matcha with no sugar, right? So as you add more and more arguments, your function, your procedure, subprogram, whatever you call it, right, becomes more and more flexible, okay? So the more argument you have, the more flexible your function is, okay? The more your function can vary, the more your recipe can vary. Previously, with just one argument, you had just 3 types of tea, right? Darjeeling, oolong, and matcha. Now, with just the addition of one more argument, you have you have 6 types of teas because you have Darjeeling with sugar or without sugar, you have oolong with sugar, without sugar, right? Matcha with sugar, without sugar, right? So the more arguments you have, the more flexible, or the more sort of uh, the more your function can achieve. That's one way of putting it. Or the more variations your functions, your recipe can take, right? Uh, Now we talked about functions that return more than one value, right? But in the previous examples, in all the previous examples, we have only returning functions that that return a single value. So how do we use, or how do we call a function that returns more than one value? How do we do that, right? So take this example for instance. Okay, this example is of a function that gets the first name and the last name, okay, from the user, from the user, okay, and the function is called get full name. That's the name of your function, okay. And what it does, it asks the user, it prompts the user for to enter the first name and to enter the last name, and then saves these into variables first name and last name, right? And then it returns first name comma last name, right? uh, just so you know, it's just an FYI, what's happening here is this thing is called a tuple, okay. You don't need to know what a tuple is right now, but just it's good to know that this is not uh, it's the data structure actually behind this is called a tuple. What a tuple is and how to use it is not part of this course, but when you learn data structures and so on and so forth later on, you'll see what a tuple is, okay. Anyways, so that's how the function returns two values, right? Now, how do we call the function? Just like previously, when a function returns something, right, sort of like this, right, we can save this in a variable, right? When a function returns one thing, we can save it using one variable. When a function returns two things, like here, we will use two variables. That's it, simple, right? So this function returns first name and last name. We will also use two variables separated by a comma. This one is important, right? Separated by a comma to store the result of this function, right? So let's go back to the example of sum and difference, okay? So in this case, the sum and difference, okay, this function returns the sum and difference in this syntax, right? S comma D. So let's say you want to call this function, what would you do? Let's say, right? So you would have S comma D equals get sum diff, and then two numbers, let's say 5 comma 10, and then let's say you print S comma D, and that will print 15 and a space and then -5, right? Okay, so your just like the arguments that you pass to the function must match the function definition itself, right? So the function takes two numbers, you also must pass two numbers, right? This has to match, right? In order to use these values, this will also match, okay. Just a quick note on technicality, it isn't strictly speaking required for this one to match as well. So, and by matching I don't mean these names, so you can also say sum diff, sum comma diff equals sum diff equals get sum diff, and that's okay, right? This is not what I mean. What I mean is you can also say things like x equals get sum diff, and then two numbers 5 10, right? You can also say this. So although getSumDiff is returning more than one argument, you are actually saving it in a single argument. This is perfectly valid, okay? It's technically it's correct. But then you have to get these values s and d from within this x, okay? So this x is like a composite variable. By the way, this is not a thing. This does not exist, okay? I just said composite variable because what it's technically called is an object, or theoretically it's called a data structure, okay? But anyways, so uh, you can actually store the result using a single variable, but then you have to do some trickery in order to retrieve these individual variables, right? So a better way of doing it is, or an easier way, or an intuitive way of doing this is using using the same number of variables to store the data, right, as the number of variables that the function returns. Okay, so the function returns two variables, you also use two variables to store these variables. So then there would be a one-to-one correspondence. So the first name would be saved in the fname variable, right, and the last name would be saved in the lname variable, right? That's it. Essentially it's very similar to calling a function that returns one argument, okay, except you have two arguments, two variables separated by commas, right, to save the results, okay? Now, as we know that we have procedures which are functions with no returns, and how do we call them? Again, it's very similar to calling functions, right? You call that function by its name. So in this case it's display sum. You give it two arguments, 5 and 10, which would replace num1 and num2 here. So this will be replaced by 5 and 10, and then this would be replaced by 5 and 10, and the result would be replaced by 15, and that's it. Previously this 15 would have been returned, right, back to the caller. So you could say things like x equals display sum, right? But since there is no return statement like here, this return statement does not exist in this function, the function won't return anything. So this, a statement like this would be invalid. This won't be a valid statement, okay? This would be invalid. And that's the only difference between a function and a procedure, okay? And that is why I said in the beginning, Python does not differentiate between a procedure and a function. It's all the same, essentially, okay? A procedure for Python is just a function with no return values. That's it, okay? Now, the reason we might want to have procedures is, now in this example, right, you might think, okay, it makes sense if this function returns the sum, right? It makes sense. Instead of printing the result, it might make sense to return the result, right? I think it's a sensible choice. But sometimes, like I said before, you don't want your function to return something per se, but you just want to package a piece of code into a block. That's it. That's all you want to do. And the example of such a code is sort. It's a very widely used, an extremely useful procedure, okay? And what it does is it has like a very complicated set of steps, okay? Tons and tons of algorithms there for sorting, right? And all it does it takes a list of numbers, or strings, or whatever have you, right? And in whatever order they have, like right, in not any particular order, and it will give you the sorted result, right? It will give you the result in the ascending or descending order based on what you choose, right? It will give you 1 2 3 4 5 6 7 8. So that's the procedure, okay? It does not return anything. It doesn't have to return anything, okay? But in theory, or sort of conceptually, a procedure is used for larger problems, okay? whereas a function is used mostly for smaller problems. Okay, a procedure is it's like entire algorithm. Okay, that's the difference between a function and a procedure conceptually. But Python does not differentiate between how you define a procedure. See this? It's exactly the same as how you define a function, except it does not have a return statement. That's it. That's the only difference. And when you call the function, you cannot say things like x equals, because the function does not return anything. So you cannot save a return type, save the return value, because again, it doesn't return anything. Okay, so you just call the function like this. Okay, so previously we have been using functions in expressions, like we have been using things like print, display, right? So this print is a function, this display is a function, and you are using this display function inside a print function. Okay, now you can do this because this display, as you know, returns a value, right? So if a function returns something, it can be used in an expression. If a function does not return anything, it cannot be used in an expression. Cannot be used in an expression. Okay, remember this. A function can be used in an expression only if it returns something. If it does not return anything, in other words, if the function is conceptually speaking a procedure, you cannot use that function in an expression. Okay, and that is why normally procedures are used in larger programs. Okay, now the last concept here is the concept of formal and actual arguments. Okay, so what is a formal argument and what is the actual argument? Okay, a formal argument essentially is used as a placeholder in function definition for users to pass values into, and the actual arguments are the actual values that are passed to that method. Okay, so if you think of a program as like a coffee machine, okay, like an espresso machine of some sort, okay, some sort of an espresso machine or something, right? A black box. You don't know what's happening inside the machine. You know that it has two sort of cups in here, right? So these cups are like you can't see the cups. You only see the holes, two holes, right? So what these cups represent is or are formal arguments. This is a coffee machine. Okay, so these cups represent formal arguments, which are like placeholders. Okay, placeholders for storing or for giving actual data. Now when you make coffee, right, you put coffee grinds in here, right, and you put water in the other one, right? So this coffee and water are your actual arguments. Okay, so a formal argument is nothing but a placeholder for your actual arguments. Okay, now look at this definition, this function definition. Okay, this function returns the product of two values. Simple, right? Now it takes two arguments, n1 and n2. Now think for a moment, what are n1 and n2? Are they formal arguments or are these actual arguments? Okay, so again, remember that these are formal arguments are placeholders. Okay, and if you think about it, if this multiply were your coffee machine, these n1 and n2 are nothing but placeholders, right? And when you actually call this multiply, you replace the values of n1 and n2 with whatever values you want to multiply it with, right? So essentially n1 and n2 are formal arguments. Okay, n1 and n2 are formal arguments. Okay, so actual arguments are copied to formal arguments. Okay, just like coffee and water are actual arguments which are poured into, or like think of pouring as coughing. Okay, pouring equals copying. These formal arguments, these actual arguments, coffee and water, are poured into these cups, which are formal arguments, right? Pouring is copying, okay? So when you call this multiply, when you call this function called multiply with two numbers, let's say 5 comma 10, what's happening here is these 5 and 10 are actual arguments, and you're replacing the placeholder n1 with 5, and you're replacing the placeholder n2 with 10, right? So the actual arguments replace the formal arguments, okay? So in this case, x equals float input, right? Y equals float input. So this is where the user enters, let's say 5 and 10. And then you call the function multiply, and then you pass the values of x and y. So x and y are called actual arguments, okay? So what you're doing here is, in the definition of multiply, you have two placeholders n1 and n2, and you're replacing these placeholders with the values of x and values of y, which, let's say 5 and 10, right? You can also say multiply and then pass it the actual numbers. You can say 5 and 10, right? You can also pass expressions. Remember, you can always in function definitions or bodies or expressions, you can have constants, which are like 5, 10, right? You can have variables, or you can have expressions, right? You can have expressions, right? So you can pass multiply 5, 10, in which case 5 would replace n1 and 10 would replace n2. You could say multiply x comma y, in which case the value of x would replace n1, right? N1 would be the value of x, and n2 would be the value of y, right? And then it would result in whatever the values of x and y is, like 5 and 10, right? 5 and 10, right? Similarly, you can also pass expressions, right? Instead of variables, you can pass expressions. So you can say x plus 2 and y divided by 2, right? So if x is 5 and y is 10, these expressions would be evaluated first before it is passed on to the functions, right? So what's happening is, when you say w equals multiply x and y, what Python does internally is it replaces the value of x and y. Give me a moment here. It replaces the value of x and y with whatever x and y actually is, right? So let's say you entered 5 to x and 10 to y. What Python will do is replace x with 10, replace y. Replace x with 5 and y with 10, right? Replace x with 5 and replace y with 10, and then it will call multiply with the values of 5 and 10. And as we know, multiply has two placeholders, n1 and n2. n1 will have the value 5, n2 will have the value 10, and the result will have the value 50, which is what we return, right? 50. So essentially, when you say multiply, this entire thing would be replaced by 50. And when you print w, it's replaced by 50 as well. Okay? Similarly, you can call multiply with expressions. Okay? And what happens is, these expressions are evaluated first. So x, as we know, is replaced by 5. Y is replaced by 10. Next, Python will evaluate these expressions. So what is 5 over 2? 7. So it will replace this with 7. And 10 over 2 is 5. So it will replace with 5. And then it will call multiply 7 comma 5, which again, as we know, n1 and n2. n1 will have the value 7. n2 will have the value 5, right? And the result would be 35. And that's what this would be replaced with. Okay, so to summarize, the formal argument is like a placeholder. Okay, formal arguments are placeholders. Okay, like the things in the coffee machine in which you pour coffee and water, right? And the actual arguments that are the things that are copied to the formal arguments. Okay, so in this case the coffee and water are the actual arguments. Okay, so the last topic is how a function executes, and you might have, I'm sure you have an idea of what happens when a function is called, right? So you first define the function like so: def, name of the function, parentheses, the arguments, and a colon, right? And then you have all these block of statements and stuff, right? And then you call this function. Okay, so the first thing that happens is the function won't be run unless it's called. So before this function is executed, before all these are executed, right, Python will first execute this function, that's number one. Then it will execute this function, this statement, which is number two, and then it will call this, right? Now when you have something like this, x equals larger, Python always evaluates the right of the equal to sign first, right? So this will be evaluated first. Okay, so the larger AB, again the value of A would be replaced by the value of whatever the user enters, right? Let's say 5 and 10, that's what the user entered, right? The value of A would be replaced by 5, the value of B would be replaced by 10. Okay, and the execution of the statements of the main code would be interrupted. At this point the main code stops. Okay, and the function and the control goes to this part, the first statement in the function body. Okay, the block of statements that you have inside the function. At this point the main code stops executing, and the execution, if you think of an execution as if you think of a pointer, okay, that points to sort of which line is executing right now. At first it's this line, that's number one, and then this line is executed, and then it's this line. Okay, and then this line is executed as well, and it's this line. And what happens here is, as soon as we encounter the function call, the control of execution goes to this line right here. Okay, if the function needs any inputs, the actual arguments are copied to the formal parameters, right? So if it's 5 and 10, those would be copied. So val1 would be 5, right? Val2 would be 10. Okay, the statements in the function are executed. So if 5 is greater than 10, it's not, so I'll return 5. I'm sorry, I'll return 10, right? So all these statements are executed. Okay, and a value is returned, which is optional, by the way. An optional value is returned from the function to the caller. So returning a value essentially means you're replacing this entire thing with the value that is returned, right? So val2 is, remember what this is? This was 5, this was 10, this was false, this evaluated to false, which means we returned 10, right? So you can replace the entire thing with the value that was returned, which is 10. Okay, and then you print 10. Similarly, you can also call the function from within a function, right? So you call this larger function within the print function, and as usual, okay, at this point the execution stops. It goes back to this function body, right? X is, as we know, 10, right? X was 10, and a plus b is 15, right? A is 5, b is 10, so a plus b is 15. So these are the values that would be copied to larger, right? So this would be val1 would be 10, val2 would be 15, and as usual this will return 15, and the entire thing, the entire function call would be replaced by 15, and that is what we print, right? So the final result would be 15. So that's how your function executes, okay? And that's the end of this lecture. I will post some simple exercises for you to do. Some of them would be graded, okay? Some of them would be for practice. Go through this video and I will send you a mail hopefully soon. And if you have any questions, we can set up Zoom appointments or what have you. And I'll answer your questions, or if you have any doubts or if you need any clarifications on any topic, I'll help you with that as well. Okay. All right, guys. So that's it. Yeah, stay safe, and I'll hopefully get the next lecture out soon.